Imagine the Mojave Desert south of Las Vegas, the sun beating down relentlessly, not a drop of water in sight. On a small bush full of tiny pink and white flowers, you see a well-camouflaged caterpillar. You watch for a moment as an ant approaches it, afraid the ant might attack, but no, the ant is guarding it. Right in the middle of our desert, you have just witnessed one of the world's most fascinating relationships, a mutualism between caterpillars and ants. This important mutually beneficial relationship has been studied throughout the world for over 100 years. So how does it work? Some caterpillars have developed specialized ant organs on their bodies that both entice and reward ants for tending to them. The most important of these is the dorsal nectar organ, which produces droplets of nutrient-rich nectar right on the caterpillar's back where ants can easily eat it. In return for this reward, ants provide protection to caterpillars from predators and parasites. Until recently, it was widely believed that the dorsal nectar organ was responsible for maintaining this relationship. However, work by Masaru Hojo and colleagues in 2014 showed that ants will still tend partner caterpillars even if their dorsal nectar organ has been rendered incapable of delivering a reward. It turns out ants were responding not to the nectar, but to communication signals on the bodies of caterpillars. The compounds making these signals can be classified as either simple or complex. Hojo and colleagues found that partner caterpillars have complex compounds on their bodies that closely match those of ants, making them better communicators than non-partner caterpillars with simple compounds. They then hypothesized that simply by analyzing the complexity of these compounds, we can determine whether this relationship is present and how strong it is, because they believe that these compounds are driving this interaction. In my data, my raw data, you can see represented by each of these black dots the potential communication compounds found on the bodies of individual ants in this group and across different groups of caterpillars. By looking at compounds that are found across groups, we can pinpoint good candidate compounds for these communication signals. This research has great implications for conservation. By better understanding how communication works in this friendship, we can better begin to protect it, and in turn, some of the rare butterflies that we are lucky to have here in the Mojave. Thank you.